So welcome back, everyone. So last class, we learned about the goals of AI, right? Last session. So this session, we will be learning about certain disciplines of AI. Okay. So wherein, I think these are only few disciplines of AI. There are so many more disciplines of AI, wherein which we can use AI in all, I would say prospective fields, right? So this is one thing that we are seeing, and here comes some of the advantages of artificial intelligence. So it says it basically reduces the human error. As I told you in my last session, the main purpose of creating this technology is basically to reduce the human work. And here it says, okay, to reduce the human errors, because as humans, okay, we have the saying, right, you know to err is human, okay, and to forgive is like God, right? So this is how we are. And so it says the second advantage, it says it takes risks, okay, instead of humans. And it says it is available 24 by 7, yes. And it also helps in in the repetitive jobs that we are doing, okay. And it could be any work that we are, for example, some document work that we are trying to do, and AI would help us doing it instantly, okay. So that's one more thing. And it helps us in order to come up with faster decisions. And the digital assistance also is one of the advantage, okay. For example, okay, let's say you want to connect to a particular it could be anything, okay, for that matter, any website, or let's say any particular person that you would want to connect to. Imagine you have a chat bot there, okay. So again, that involves AI. So how does it happen? Yeah, it's all because of AI. And the daily applications, okay, like we have the Google, we have the Siri, we have the many more applications that we're seeing. And the next thing, it also helps us in inventing new things, right? Because every day is not the same day, so every day we come across so many complex problems. And this is going to help us in achieving it, or let's say in solving them. So along with advantages, we also have certain disadvantages of AI, wherein which says at a high cost of creation, okay. So the creation, that means it takes a lot of time, and it takes a lot of hardware and software, as well as we need to repair it, and maintenance. So all of these things involves, so it includes a lot of money there. And the next thing, it says it makes the human lazy, yes, because all the systems are doing it. And that's one more thing wherein which humans tend to become more lazy. And the next thing, yes, it's again going to have a huge impact on their employment, wherein which many people would lose their jobs because the AI does it for them. And because they are systems, and there are no emotions that can be connected with them. So unlike humans, wherein which humans are filled with emotions, whereas systems, we do not see this, and that is also said to be a disadvantage. And the next thing is the lacking out of box thinking, wherein which, because AI follows, I would say, it learns, right? It learns a lot of things, and every day it learns a lot of things, and then it's going to adapt you know to those kinds of solutions. So let's say a new problem is there, like it doesn't know how to enact, or let's say how to predict, or know how to solve them without the human intervention. Because for us humans, I think a new problem comes, we think about a lot of strategies in order to solve the problem. But whereas for an AI, it is it's going to lack out of that. It's going to lack of this out of box thinking. And these are certain branches of AI, wherein which we're going to see this in logical situations, or let's say logical AI, wherein which as I told you, in order to take a specific decision, so how would it do? And in the searching problems, that's what I said. So here comes the example they are telling, they're trying to talk about the moves within the chess, okay. So what is the what is the best possible move that that would help you to win the game, or so that's the search criteria there. And then the pattern recognition. So what do you mean by pattern? So like how we see, okay, things in our day-to-day life, similarly the systems also try to follow, they're being fed with a lot of observations, a lot of data. So they try to learn on on those. So the next one, it says a representation. So basically how this how the problems are being represented, the mathematical formulas, okay. For example, if you remember in our in our maths classes, when our teachers used to try to derive a particular problem statement, okay, in into a particular equation. So So that's how is, that's what is called as, representation using some, mathematical formulas and, the symbols that we would use, okay, to represent them. Okay. And the next thing is, in the inference, as I said, inference basically talks about the conclusions. So what are the conclusions that we can withdraw based on whatever problems that are being, given to us? So these are some of the branches, and we also have the common sense knowledge and reasoning, wherein which it says non-monotonic reasoning and theories of action. That mean, what do you mean by monotonous? So it's like, you're just thinking, in one continuous direction, right? Whenever we say non-monotonic, that means it involves, okay, whenever we say knowledge, data again, and then it involves, like, what is the strategy that you would adapt, okay, in order to solve that particular problem, and what is the theory that you would use behind that, okay. And as I told you, okay, learning from experience, yes, because a lot of data is being fed, and the system constantly tries to learn through the previous experience. And the planning, so whenever we say planning, again, I told you, planning is nothing but a sequence of steps, or let's say sequence of actions that you take, okay, in order to execute a particular problem, or let's say in order to execute a particular solution for that particular problem. And we also have epistemology. So it says it's a study of, basically it's a study wherein which it deals with, many kinds of knowledge, okay, that are basically required for problem solving. So we use that particular study approach is called as epistemology. And we have ontology, okay, so it says it's a study of the kinds of things that exist. Okay, so these are the few branches of AI, and these are, the various applications of AI. Yes, of course, in our day-to-day life, we have seen more than this. Okay, this is just a simple gist of, how where AI can be used. Okay, I think the pictures are very clear enough to tell us what it is. Okay, and the next thing that we would be, trying to analyze is about the internal representation. So we'll just see what this internal representation is. So it says that in order to act intelligently, a computer must have knowledge about the domain of interest. So the domain DOI, that is the domain of interest, is very, very important here. And since knowledge is contains facts, and when we say facts, as we all know, okay, they don't have meaning to them, right? They are just data. And it says this knowledge needs to be presented in the form which is understood by the machine. Yes. Okay. And it says it's a unique format. So this particular unique format, which helps, okay, the system understand, right? That is called as internal representation. And it says it's nothing, it basically contains plain English sentences that could be translated into an internal representation. And they could be used to, answer based on the given, sentences. So here come some of the properties of internal representation. So whenever we say internal representation, of course, it shouldn't have any confusion, right? So we need to avoid the ambiguity in the words that we use, okay, in order to represent the data there, okay. And it says that, you should also remove all the referential ambiguity. Okay, we'll try to understand what that referential ambiguity is. Okay, that means when you're referring to someone, you should be very clear. Okay, let's say, for example, it could be any person. Okay, let's say ABC. Okay, let's just take his name, ABC. So if I'm going to represent him, I need to be very specific. I shouldn't use some other words wherein which, okay, it might lead to confusion, because we as people, yeah, we understand whom we are talking about, but for systems, yeah, it must be very, very clear. So it says internal representation should avoid the word sense ambiguity, and it says the word sense ambiguity arise because of multiple meaning of words. Okay, so we all know that. Okay, right. For example, here it says Raj caught a pen, Raj caught a train, Raj caught fever. So though we have the same verb caught, but where are we basically using it, and with what? Okay, objects that we are using it with, right? So that also, should not have any confusion. So these are some of the important properties of internal representation. And I said, okay, just now I was just telling you about the referential ambiguity. So here comes the example wherein which it says Raj said that Ram was not well and he must, okay, be lying. Okay, or he must be lying, or he must be lying. Okay, so in that way, Raj and Ram, so who is this he, right? We don't know who this he is. So all of these things should be avoided, okay, in your internal representation. Okay, these are some of the problem representations in AI, wherein which, okay, whenever we are trying to talk about a problem, we need to define that problem precisely. Only when we define the problem precisely, we would be able to get the right solution. And most importantly, we need to analyze the problem, right? So after definition of the problem, it's important that we do some analysis on it. And whenever we say analysis, we need to find out, okay, what is important strategy. Whenever see it says important features, so what's the strategy that I would use, okay, in order to solve this problem. And the next thing it says, it's isolated and represent. Okay, that means isolated means every feature should be on, I would say, it should be independent of the other, right? Only then you'll be able to analyze, right? So there are various I would say factors that we would, or let's say the parameters that we would use in order to, we would analyze in order to solve the problem. So we need to identify them as individual entities and then try to represent them. And then the next thing is, to choose the problem solving technique. So this is very important, okay? As we have all studied, even in software engineering approach, we see this, that, we have to choose the right model, okay, the right approach to solve a given problem. If not, it becomes a huge mess. So even in AI, it is very difficult if you are going to, if you're not sure of what technique that you would use, then it would not end up giving you the right output, right? So these are certain problem representations in AI, and the rest of it we will see in the next session. Thank you all.